Okay, continuing our video on obstacles in factoring. We have this idea of factor by grouping, zero product property, completing the square, which was talked about in the last video, zeros, quadratic formula. We're going to focus mostly on this factoring by grouping. And so what we have here is a problem. This will be a teacher-led example. It says that we want to find the zeros or the solutions to x cubed plus 3x squared minus 9x minus 27 equals 0. Can we do this by factoring the equation? And what's really, really important to know is that you have all the tools necessary to do this problem, because we've talked about long division. And really the process at this point would be like, let's check. And so as I look at the negative 27 at the end, I know that negative 27 must have come from, if it's factorable, negative 1 times 27, or negative 27 times 1, or better yet would be like x minus 3, there's negative 3 here, a positive 9, or potentially an x plus 3. And so this process is more of like a guess and check. And you're definitely going to use this in pre-calculus when you get there. But I'll go through and I'll just try it. Like, all right, let's see, x minus 3. How many times does it go into x cubed plus 3x squared minus 9x minus 27? And so how do we get the x cubed? X squared times x is x cubed minus 3x squared. I have to change the signs because I'm subtracting. This gives me 6x squared minus 9x. So now I need a plus 6x. That gives me positive 6x squared minus 18x switch the signs. This gives me 9x minus 27 plus 9. So plus 9, 9x minus 27, switch the signs, and 0. If I get a remainder of 0, I know that that must be a factor. So right now I know that x cubed plus 3x squared minus 9x minus 27 must equal, in factored form, x minus 3, x squared plus 6x plus 9. But I know I can continue factoring this, so I get x minus 3 times quantity x plus 3 times x plus 3. And so now you have the factored form. You set them equal to 0, and you can use zero product property. But there is a different process to be able to do this. It's very, very helpful. It relies on the greatest common factor and understanding how to factor in general, but this is called factor by grouping. And you take a moment and you pause whenever you're looking at your expressions. So x cubed plus 3x squared minus 9x minus 27 equals 0. Okay, I kind of noticed that there are GCFs littered within this. Like, if I look just at the first part here, I notice that these both have x squareds. And then for the next part, I notice that both of these have a negative 9 in them. And if I factored those out, so you just kind of try it. So x squared, x plus 3. If I factor out the negative 9, that becomes x. And then that would be also a positive 3. Oh, something nice occurs in that both of these terms are separated by addition or subtraction, have an x plus 3 in them. And if I factor that x plus 3 out, kind of thinking about GCF, it's a factor. I'd have this on the outside, and then I'd have x squared minus 9. So these two kind of got factored out. We're used to putting our parentheses or our binomials in to an equation, but sometimes we factor them out. And then I can have x plus 3. If I factor this, it's x plus 3 again, x minus 3, and I have the same three factors that I got from the previous method. This isn't the only way to look at it, though. You could also look at it like this. X cubed plus 3x squared minus 9x minus 27. Maybe you didn't notice the GCF in that manner, but you kind of think, well, 3 and 27 relate the same as 9 and 1. There's like ratios involved. And so you rearrange this, x cubed minus 9x plus 3x minus 27, 3x squared, sorry, equals 0. And I'm like, oh, if I factor the x out here, I'll get x squared minus 9. If I factor a 3 out there, I'll have x squared minus 9 also. And so now these two share a common factor, which is great because I could factor that one out. So I have x squared minus 9 times what's remaining, but x plus 3 equals 0. And then I factor these out. And again, I have the same three factors that I can use with the zero product property to find the solutions. Okay, and if we kind of build off of some of the things that we learned today, the solution set would be x equals negative 3, x equals positive 3, and x equals negative 3 again. This would count as multiplicity of 2, just to build in that vocabulary from earlier today. So pause, take a moment to reflect and think about this. Thank you.